Hi guys, this is my second YouTube video. This time I'm gonna talk about the host gas chemistry. So if someone wants to look at the outline of host gas chemistry, it's also called supramolecular chemistry, which describes the complexes that are composed of two or more molecules or ions that are held together in unique structural relationship by forces other than those of the full covalent bonds. Host chemistry exhibits the best idea of the molecular recognition and interaction through non-covalent bonding. When someone talks about the non-covalent bonding, there occurs four commonly mentioned types of non-covalent interactions, namely the hydrogen bond, ionic bond, van der Waals forces, and the hydrophobic interaction. Although the host-gas chemistry shows a beautiful relation between them, yet the fundamental concept of this discipline is not much simple, so there has been a challenge in learning the basic concept on it. The reason why it is a challenge to know well about these molecules is that the large giant molecules are the result of non-covalent interactions, and this non-covalent concept is different from the normal covalent bond, which makes one difficult to understand well about these molecules. Supramolecular chemistry is a new discipline first reported in the 19th century. Also, the idea of the non-covalent bonds was not clear until the first 20th century. This is why the knowing of these molecules suffers from the limited information. Also, the host gas chemistry is also termed as the chemistry beyond the molecule. The word here itself shows the complexity in learning these molecules. So these were some points why I found host gas molecules idea to be challenging to know. So when someone has a problem, he or she definitely wants to resolve it. Same way, my issue was with understanding the beautiful large molecules, which we call the supramolecules. It was not that much hard to get the idea as I thought it would be before. Well, every time my best tutor is a Google, which is ready to teach me whenever I want. So I search on the internet to visualize the 3D picture of the large molecules, which gave the idea how small gas molecules are incorporated within the large host molecules. In addition, I searched for the published papers on official website of American Chemical Society, and it helped me a lot to come up with the core idea of the host gas chemistry. I got a good example in one of the papers that gives a clear basic concept of host gas recognition in regard to a sample preparation of analytical purposes. So what are the cyclodextrins? Well, they are enzyme modified starch derivatives which are non-toxic, environmentally friendly sugar-based macro rings consisting of D-glucopyranose units. Basically, there are three different types of cyclodextrins. The alpha cyclodextrin with 6 different members, the beta with the 7, and the gamma with the 8 different members. Here below that you can see a good example of host gas recognition in regarding to the cyclodextrins. We know very well that the sample preparation is a crucial step in any analytical method, especially in chromatography, where the samples should be homogeneous and free of any interferences in them. For this purpose, cyclodextrins are effectively used. You can see here in the first step of the sample preparation, the samples interact with the cyclodextrin-coated observer, which can selectively retain the target analytes from the dilute complex samples. The impurities are then removed from the mixture, and finally the retained analyte is then eluted for analysis by adding the competitive complex forming analytically inert acid. In this process, the host keeps its guess with the best on the which had the best on the space available on it. This competitive displacement principle has been successfully used and validated for different analytes. So this example helped me a lot to come up with the idea of the host and gas chemistry. So I said there are several problems during the learning phase, but as long as there is a problem, there should be a solution.